Hi there. This is my presentation on React and Redux, and today we're going to cover what is React and Redux, how to use React and Redux to build web applications, and what are some of the best practices on using these tools based on my personal opinions and experience using them. So let's get started. So first off, what is React and Redux? React is a flexible JavaScript library for building user interfaces. It lets you compose complex UIs from small, reusable pieces of code called components. Components use state and props to determine what HTML to display. As an application grows, keeping track of each component's state can become unwieldy. So Redux is a library for state management. It helps you write applications that behave consistently because most or all of the application state is stored in one place. So let's talk a little bit more about state management. When React devs talk about your application state, they're typically referring to the state and props or properties that make up your component. State is comparable to the attributes of a component. So just like how an object has certain attributes, components have attributes that determine how they function and display. So on the right hand side, you can see that we've just got a simple component called a custom button, and that button has some state set on line 4 where loading is set equal to false, and then in the render you can see if this dot state is loading, then display please wait. If the button's not loading, then display the button with the ability to click it, and if you click the button, then it sets loading equal to true. So this is just a basic example of how state is used within a component to display one thing versus something else. So the other piece that we have are props. So props are comparable to arguments passed into a function. They are properties passed in by another component, and props can be numbers, strings, arrays, or even functions. So pretty much whatever you want. So on the example on the right, this time we have two components. We've got a list component, and then we've got a list item. So basically the list would render multiple list items. And you can see around line 3, we declare a couple of JavaScript objects that contain the information for the list item. On line 12, we iterate through those list items, and then we render a list item, and we passed the list item as a prop. So line 13, you can see list item equals list item. And then on line 27 in the list item class, that data will be available through this.props. So I can say const list item is going to equal this.props.list item, and that information can be used to display the list items text or properties or values or whatever you need to do with the data that you pass it. So now we're going to take a little bit of a look at Redux. So first, just focus on the graph on the left. So this is the basic Redux flow where you have an initial state. The state defines the UI and tells the UI what needs to be displayed. In the UI, when a user types in an input or clicks a button or does something, that fires off an action. The action will have some sort of data that it's going to pass along to a reducer. So if you typed into an input, it's going to take whatever you typed, and that will pass it to the reducer. The reducer decides which piece of the store to update. And then once the store updates, that's where your state is contained. So that drives the UI. So that's kind of the flow of how changing something in the UI is going to update the store, which is then going to change what is displayed in the UI. So you can see the initial state in the top right corner. So currently I've got a book object and a user object stored in the state. And then in both of those, they drill down a little bit further. So I've got books within the book, so that can contain multiple books that you have saved so that you can display them in a list, or we've got the form, and the form has certain attributes that contain the current value for each input. And then we have errors, so if there's any errors, you can display them properly, and a loading flag to let us know if the form is loading or not. So you can see we've got a blank form and all the attributes are blank currently. So then here, we said the UI will dispatch actions. So on line 4 in the book form component up top, you can see that I'm importing update book form, which is an action from the book, from action/book. On line 12, I've got a function that handles a change. And you can see on line 13, it says this.props.dispatch. And then I'm going to dispatch the update book form and pass that the key and the value. So basically the key is the attribute that I want to update, and the value is the value of that attribute. So on line 23, there's an onChange handler. So onChange, call this.handleChange, and then we're updating the name, so we pass that. So basically when you type into one of those inputs, that will trigger the onChange. The onChange will pick up the new value and call handleChange. That's going to dispatch the action that's called update book form, and that will pass the key, which is the attribute I want to update, and the value that I want it to be updated to. That'll pass that to the reducer. So if we see source actions book down below, that's where I'm importing that function from. So line 3, update book form, it accepts a key and a value, and then it just returns a simple JavaScript object with a type equal to action types dot book form update. So this is basically just a constant that is used to tell the reducer which piece of the store we want to update, and then we pass it any additional data we need. So we pass it the key, which is which attribute are we updating, and then we pass it the value, which is the value that will actually be set. So then automatically that's going to get picked up by the reducer that the action called. So in here, reducer is basically a simple switch statement that determines what should the next state be based on the action type. So on line 13, you can see it says switch action.type. So that comes from the type that we passed in previously. And then you can update different pieces of the state based on that. So if you look at line 20, that matches up with our book form update action type. And it basically says return the existing state with the form updated, with the attributes updated to have action.key is going to equal action.value. So action is how you get any of the additional data that you passed into the reducer. So you see action.type, action.key, action.value. And this syntax is used to say update action.key. If you put brackets around that, that's going to say update this value, or update this attribute with this value. So the next state is going to contain our updated attribute. So the reducer is automatically going to update the store. So the next state will include our updated value. So if we started typing into that name input and we typed H, so that's going to run through that whole flow, and by the time you're done, your attributes will be updated with the key was the name and then the value was H. So then that can be displayed in my UI where the form input now displays an H. Okay, so passing state to components. So pieces of state from the Redux store are passed to components through props. The React Redux library has a function named connect that allows you to specify the state the component needs access to. So the idea is you have this store that contains pretty much all of your application state, but not all components need access to the entire store. So what you do is you give each component access to small chunks of the store so that it has the state that it needs. So in the example on the right, on line 2, you see I'm importing that connect function from React Redux. If you look down to line 47, that's where I call that connect function. So when you're exporting the class, you say export default, connect, and then the first argument that takes is what part of the state am I connecting from the store? And then the second part of that is the actual class that you're applying it to. So in line 47, you see I say connect map state to props. So that is a function that takes the existing state and will basically break down the pieces that the component's going to need access to. So you see that on line 42, I'm returning a JavaScript object, and I'm saying make a book available and set that equal to the current state.book. So then on line 17, when I'm actually rendering the object, I'll have access to the store at that point. So I can say the current attributes are going to equal this.props.book. And then from there, you can drill down further to the data that you need. So this.props.book, .form, .attributes is really what I need in this circumstance. So the attributes are used to set the current value of each input. So I've got attributes.name, attributes.author, and attributes.genre. Okay, so that's kind of the basic, like, how do you use React and Redux in a nutshell to drive the UI and keep your state in one place. So now we're going to start hopping into more of kind of like best practices. So components versus containers. It's a good idea to separate components that are aware of the Redux store from those that don't need access. Components that need access to the store are called containers, and these are your smart components. Components that don't need access to the store are simply called components, and these are your dumb components. So the example on the far right, that's an example of a container. So at the very bottom, you can see I've got the export default connect. I'm mapping the state to the props, so that way I have access to the piece of the store that I need. And then on the left example is just that simple custom button where it has a little bit of state, but for the most part, everything is contained and it doesn't need access to the Redux store. So mainly what you're trying to do is you're trying to separate the components that are basically just dumb components that are used for presentation of stuff like buttons and just very simple like list items, things that don't have a lot of logic in them. And you're trying to split those apart from the pieces of the components that do have logic in them and rely on the state. And it just helps organize things a little bit more. Okay, so if you're working in a React and Redux project, how should you organize your file structure? So if you're starting a brand new app, I recommend create React app because that's going to install and configure all the tools that you need to use React and will basically set up a file directory or a file structure for you. So you're still going to have to manipulate the source folder, but for the most part, that will organize the setup of your React app. So if you're using Redux, you're going to need folders for actions. You're going to need folders for components, containers, constants, images if you need them, reducers, styles, and utility/support functions if you need those too. Generally, you're going to want a new file per object for your actions, reducers, and containers. So in the past examples you saw I had book and user. Say if we wanted to add like library, so you could save which library you're getting the book from, you would probably want a new file in your actions for library, you'd want a new file for in your reducers for library, and you need at least one new component or container for your library. For larger apps, you might want to consider a folder per object in your containers. So this can contain all of the objects related components. So if you don't have a folder per object, basically all of your components are just listed out in that containers folder, and it can get a little bit unwieldy once you get past 20 to 30 components. So splitting them out per folder, per object, I think helps clean things up, because then that way you can put the related components like index or list, form, new, edit, like all of the related components can live within that objects folder, which helps with organization. So on the right hand side, I've got two folder structures that you can see, and the build, config, node modules, public, and script, that's all set up by create React app. The source is actually the part that you want to focus on. So I've got folders for actions, components, which are my dumb components, constants, which are basically just strings that don't change. This was used for like roles and permissions in my app. Containers, which are your smart components, images, which are just like company logos or anything that you need, reducers, styles, and then utils is just for extra support. So then the file structure on the left of that one is the file structure that I set up for this project. So you can see we've got a couple of actions. So we've got both book and user have a file. Components, we've got a dumb component, which is home, which is basically just like a landing page for you to reach the other components. Containers, which these are my components that are connected to the store, and then reducers, and that's my suggested like how you should set up the file structure. Okay, so now we're going to talk about how to organize the store. So you're going to want a consistent structure in the store to make your application state easy to navigate. For most objects, you're going to want a spot for read-only attributes, a list of objects, and then the form-related data. So that's attributes, any errors, maybe any drop-down options, is it loading, so things like that. So you can see in the example on the right, I've got book and I've got user both split out as the two objects in my app. And then book has attributes. So these are basically my read-only attributes. So if you're on a show page and you can show and edit at the same time, when you're updating the attributes, you don't want your show attributes to get updated as well. So you want to split those out separately so that they don't update until the back end says, yes, this has been saved and updated, and then passes the front end the new data. Books is basically if you saved books that you want to look at later and you need to display them in a list, and there's an array to be able to do that. And then form is all the form related data. So we've got attributes of name, author, and genre, and then all of those attributes can have errors on them. So you need a spot for that. Genre options. So if genre was a drop down and you need to fill that drop down with options from the API, you're going to want to save that in the store. And then you need to know whether it's loading or not. Okay, so let's take a look at routing now. So React Router and React Router DOM are the main packages used for controlling which component is loaded based on the URL. You can use the link component to route to different URLs and components. So in the example, you see my source app.js. This is basically the entry point of the app and where the routes are defined. So around line 34, you can see I've got the browser router wrapped with routes in between that. So you can see there's an exact route match on an empty slash, which is basically your root URL, and that should display the home component. If the route contains /books, then you need to display the books component. If the route contains users, then you want to display the users component. And then if you're in another component and you need to link to somewhere else, you can use import link from React Router DOM, wrap whatever you want to link to in that link component, and then that will handle that using React Router. So another important thing that we need to touch on for React is lifecycle methods. So all React components have lifecycle methods that execute at specific times. So it's got component will mount, which runs before a component is about to be displayed. It's got component did mount, which runs after the component has been displayed. Component will unmount, which runs before a component is about to be removed from the page. And then component will receive props, runs before a component gets new props. So these are just a handful of the lifecycle methods. There's a few more, but these are some of the critical ones. And the idea is this allows you to have some control of when to run functions when your component just gets loaded on the page or is being removed. So you can see in the home component, I have a simple component will mount, and it basically just calls a JavaScript alert to let you know that the component was mounted when it comes onto the page. So async and Ajax. You need a library to support async and Ajax calls. So I recommend Redux Thunk for the async portion and Fetch for the Ajax portion. I'm not super tied to those libraries, but they're just the ones that I used, and there's a handful of different libraries available. So no strong opinion there, but if you're looking for a recommendation, that's what I used, and they worked out well for me. Ajax calls to an API can be dispatched using the lifecycle methods, and those can call actions. So an action can be used to send the Ajax request to get data from the API. The response from the call is then passed to a reducer, and that updates the store. So if we look at one of my components, book show, you can see there's a component will mount. So when the book show mounts, we're just setting an imaginary ID equal to 1, and then we're calling this.props.dispatch, and we're going to dispatch the get book action and pass it the book that we want to get. So from there, if we look into our actions /book, that's where I imported the get book function from. On line 29, that's where that function lives, and we pass it the book ID. On line 31, we set the URL for the API that we're going to hit. So we're just hitting localhost 3000 API/book, and then we attach the book ID to the end of the URL. And then line 33, we call fetch, which accepts the URL that we're gonna call, and then it's just a typical GET request. So upon success, it calls then. So on line 40, we parse the response, which basically just turns it into JSON. On line 41, that's when we actually do something with the response. So book is the response that we got back from the server, and then we dispatch set book. So from there, I'm going to dispatch another action which sets the book that I just got back from the API, and that will update the store. If anything errors, you can catch errors using .catch, and then you're going to want to dispatch another action that said, hey, I had an error, and then you want to set those errors in the store so that way you can display them later. So another topic that's important for single page applications is loading states and spinners. So since React is typically used for single page applications, all objects need to know when they're loading or waiting for an API response. So a spinner is typically used to indicate when items are loading in the UI, and you need to make sure that this is accounted for in your application state. So the typical flow is a component mounts or updates. It then makes an API request. From there, you know that the component you're talking about is loading, so you need to display the spinner, and then the API will respond. So then you can set the data that it gave you back and set loading equal to false, which will then hide the spinner. Okay, component libraries. So libraries have been created to help speed up the development by using pre-built components. Material UI and React Strap, which is basically Bootstrap, are both good options, so you don't have to recreate things like modals, drawers, date pickers, and other common components. So basically you can install these via npm or yarn, and then you just import them like the example on the right. So line 3, I'm importing button from React.js, which is basically bootstrap button. And then on line 21 and 26, I'm using buttons there. Um, and that's just a simple way to not have to code out my own button, but I can rely on the styling and basic button functionality of React.js. Personally, I think these things help out more with things like date pickers and time pickers, because those are a little bit more complex and are a little bit more beneficial to have pre-built. But yeah, these are the two biggies. There are other component libraries, but Material UI and Bootstrap are some of the largest ones. Okay, so how to style components. So there are multiple ways to style components, and this topic has a lot of discussion around it for React. You can use a typical style sheet, which is good because you get good reuse, but bad if the component libraries rely on inline styles. So a common strategy in React is to just add the styles to the component itself, so that as the component changes, you can just update the inline style, and that's going to change the display of the component. This makes it really hard to use normal CSS to override things, because an inline style overrides a typical CSS class. So you're either going to have to throw importance all over the place, or I'm not really sure. That it can really create issues when you have inline styles and you're trying to override them with a class. So another common pattern is just flat out using your own inline styles to override other people's inline styles. So that sucks because you've got bad reuse, but it's good because it's easy to override any component library styles. So say you really like Material UI's date picker, but it's not styled right. One of the only ways to correctly style the thing is use inline styles on the component and pass it the styles that you want to be applied. Um, Another benefit of this is that it's nice that the styles that you need are always in the component that you're working on. But it sucks because you get bad reuse. So another strategy is you could use that inline style strategy, but import them from a different file that basically just contains CSS objects. So this is good because you get good reuse, because it's kind of like a CSS style sheet where you can define all of your styles in one place, but you can still use them as an inline style to override other component library styles. So I think that this is a very good option. And if you look on the right, when I'm talking about inline styles, this code shows you what I'm talking about. So I export a const at line 6 called styles, and that has a style for the header. And then on line 20, you say style equals, and then I call that styles object, and then I call header, and then that's basically going to drop in the styles that I want applied to that h1 tag. So that's an example of just an inline style. So if I were to import that from somewhere else, basically underneath line 4, they would say import styles from, and then wherever I created that style sheet. So rather than the style being defined inside the component, I can get better reuse and reuse styles that I know I need elsewhere. But I can still use the inline styling on line 20, so that way if you need to override other like a components library styles, you still have the availability to do that. So another solution is styled components. Styled components is a library used basically to solve this problem of styling React components. But in my opinion, I didn't think it was super clean or clear. If I look at someone's GitHub page and it doesn't like click instantly, and I'm not like, oh, this makes a lot of sense, this looks really useful, then I typically shy away from it. So it is an option out there. I didn't have any luck with it, but it just depends on what app you're working on and what you're trying to achieve. So it's definitely an option out there. My personal opinion on the best solution is you usually want a combination of some normal CSS and then using the inline styles. So you want normal CSS for global styles that you need. So things like text center, you don't want to have to define that in every component that you're using. But you need the inline styles to be able to override any component library styles. So I think the best combination is using both. You want to try to rely on CSS styles as much as possible. But yeah, it's just a balance depending on your project and what tools you're using. So it's typically a combination of both things. Okay, so a few other gotchas. Deep copy is a common problem in JavaScript applications. So if you try to save the same object in two different places in the store, uh, JavaScript tries to reference the object by reference rather than creating a brand new object for that thing. So what you'll find is if you go and if you split out the same object in the store in two different places and you only update one of them because it's being referenced by reference and it's not a brand new object, it's going to update both of those attributes at the same time, even though you only want to update one. So that's kind of a common problem where you need to be able to deep copy objects so that way they don't share the same reference. So if you store them in two places and you update one attribute, you want to make sure that the other attribute isn't also updated so that they truly are two different objects. Accidental re-renders is a big one too in React. So you want to make sure that you don't accidentally re-render components that don't need to be re-rendered when you're updating them. So for example, I had an index page that had like a search thing on it. And if you typed into the search, it was re-rendering other pieces of that component that didn't need to be re-rendered, which it just makes your app slower. And if you have like a long list and it's trying to re-render a list every time of like 100 items or like 1,000 items, that's going to look really slow in the DOM, and you're going to want to address that basically. So you just want to make sure that when you're updating a component state, the thing that needs that state is only being re-rendered, and you're not re-rendering a whole bunch of other stuff based on that. Too many AJAX requests is also another problem, where you want to make sure that you don't just slam your server with like 200 requests on an initial load, because typically the data is coming from an API, and you just want to make sure that you're not accidentally sending AJAX requests for data that you either already have, or you just want to make sure it's not so split out that on an initial page load you make 200 different requests and slam your server every time. So you just want to be careful with that and try to make sure that your responses come back with as much data as possible, or the correct amount of data within that request. Something else is try to keep your reducers simple. So I've seen a lot of people that try to do some fancy stuff in your reducers where they're merging the existing state with the new state, or just trying to do like some additional complicated logic. You just really want to keep the reducers simple, so that way if you go and look at a reducer, it's easy to see that the state is just being updated with a new state, rather than trying to add any kind of extra logic in there. And then small components versus large components. So most tutorials and things, when you're working in React, they'll tell you make your components as small as possible, and like if it's over 100 lines, then like it's bad and you need to break it into a new component. But the difficulty with that is when you start working on larger apps, there is a lot of logic that drive the UI, so some of your components do become larger. And I think a better way to manage this is you want to split your components where it logically makes sense, rather than focusing is my component larger than 150 lines and I need to break that down. Really, you want most of the logic and functions that are truly contained within that component to be in the same file, because if you just break it down to break it down, it starts to feel kind of clunky, where you have to pass functions through to the smaller components, so that way you can reuse the function rather than defining it multiple times. And I just found that this was less important than everyone made it out to seem. Like, I didn't really struggle to navigate my larger components as long as they truly were self-contained and had like all of the functions and things that I needed within that component. I found that to be a value add rather than trying to split it down just to keep the code cleaner per best practices. Okay, so a few noteworthy packages that didn't really make it in here. Um, Redux Persist is a really cool package that saves the store to local storage so it can be reloaded upon refresh. So basically, if you have someone that is signed in and you refresh the page and you don't store that information anywhere, the store is just going to be reinitialized and they'll be logged out. So you need a way to be able to save the store so that if they come back or refresh the page or do something, you can at least check to see if there's an existing store saved and then reload that so that way you have the existing state. So Redux Persist is really cool. Redux Auth is a library to help you get started with authentication. It provides forms, AJAX calls for sign up, sign in, delete account, and a whole bunch more. It automatically adds the sign-in token to the header on every request, which is really cool. It also integrates very easily with Rails, which is cool. So there's a demo set up, and you can basically hook it into Rails very easily, and it integrates with Devise, and it's just a really awesome library, so highly recommend. Redux Logger logs the previous and next state to the console every time the store is updated. So this is really, really helpful for debugging. So if you're firing an action and it's not doing what you think it's supposed to be doing, it really helps to be able to check what was the previous state and then what is the new state now and why is that not what I expected. Immutable.js is a cool library to make sure that all of your objects are truly immutable. And it helps solve that deep copy problem in the store. So that way you're never going to have objects that are referencing the same thing, even though they're split in two different places. And then Google Map React. So this was the best library that I found to use for Google Maps integration. There are a couple of different options on the table, and this is the one that I like the most, so I figured I'd mention it. Okay, so that's pretty much my presentation. If you want to learn more, I've got links to Create React app, the common YouTube React tutorial, and the Redux tutorial, the complete Redux book, and I've posted the example code from this presentation. So if you just want basic examples of kind of like how to set your things up and what does a simple reducer look like and how do you make an AJAX call, that stuff is contained in the example code from this presentation. So my name is Drew Haines. If you want to find out more about me, you can follow me on Twitter. That's pretty much it. Thanks for watching my presentation.